Good evening. Can you hear me? Can you hear me? Okay, thank you. Okay, the theory part of the biomolecule lesson we already discussed, right? Today we're going to discuss questions of biomolecule lesson. Before that, next Tuesday, 6:30, normal our class time, you have an exam. Okay, exam time and the structure of the paper I will share into our revision group. Okay, this is revision paper number 1, revision exam number 1. Paper structure is still, paper is not finalized. I will share the structure of the paper soon. Next Tuesday. You have 1 week. Please go through again all lessons. Lot of questions from biomolecule lesson. Therefore, go through all theory parts again and other all lessons we completed, go through again. Okay, let's go to the paper. Okay. MCQ completed and 2015 structured essay question discussed, right? Let's come more into 2016 A-level biomolecule question. Consider the following dipeptide. Consider, are you clear this? Are you clear these letters? Yes or no? No issue, right? Pain on it. Joel, it is clear, right? Okay. Consider the following dipeptide molecule. Dipeptide molecule. Three bonds in it are labeled P, Q, and R. Three bonds, P, Q, and R. Three bonds mentioned in labeled in the on the dipeptide. What is the letter in the label assigned for the peptide bond? Okay, what is the PQR? What is the peptide bond among PQR? Among PQR, what is the peptide bond? What's the peptide bond? Others, Dihini, Fatima, what's the peptide bond? Yes, very good. Yes, very good. Always, I already explained in the lesson, the peptide bond always form between two amino acids, right? Between two amino acids. I will draw and explain again. This is alpha carbon, COOH. COOH. What is the name? Carboxylic group, hydrogen group, NH2 group, amine group, and R carbon chain. R carbon chain. Yes, all are correct. All are correct. Okay, this is a common structure of one amino acid. What are the parts? Alpha carbon, carboxylic group, amine group, hydrogen group, and R carbon chain. It's a long R carbon chain. This amino acid combine with other amino acid. This combining bond we called as a glycosidic bond. This combining bond we called as a glycosidic bond. This is our carbon chain. Okay, now what happened? This OH group and hydrogen group combine. OH group and hydrogen group combine and release one water molecule, one H2O molecule, release out. Then between this carboxylic group carbon and amine group nitrogen, a bond is forming. A bond is formed between this carboxylic group carbon and amine group nitrogen that we called as a peptide bond. According to this diagram, it is Q. According to this diagram, it is Q. Always peptide bonds form between two amino acids. Between two amino acids. See? This is the alpha carbon. This is the alpha carbon. COO, OH, and this is the nitrogen amine group, one hydrogen. Next side, the remaining hydrogen is released as by water, released as a water molecule, right? Released as water molecule. This is R carbon group, hydrogen and amine group, carboxylic group, hydrogen R group and amine group. Okay, Q is the peptide bond. Q is the peptide bond. Q is the peptide bond. Name the enzyme group that can be used to break the peptide bonds in protein. Okay, what is the enzyme? What is the enzyme that we can use to break the peptide bond? Yes, very good. Very good. Protease enzyme. Protease enzyme. Yes. By protease enzyme, we can hydrolyze and break down protein into its simple form, it's into amino acid. Name a test that can be used to identify the presence of peptide bond. I told in the protein identification test we discussed in the lesson, we mainly identify peptide bonds. Then peptide bond present mean it's contain protein. That's how we identify. What is the reagent? What is the test? What is the name of this test? What's the name of this test? Very good, biurate test. Biurate test. Biurate test. Biurate mean what is a chemical? That's a mixture of copper sulfate and caustic soda. Copper sulfate and CuSO4 plus NaOH caustic soda mixture. Copper sulfate and sodium hydroxide. It's a mixture. It's a mixture. Okay. Structures of some biomolecules named W, X, Y, Z are given below. Okay, before go to questions, this type question, first you can identify. Now you already know all biomolecules, right? First of all, you can identify these biomolecules. Okay, what is this? What is this? What is this monosaccharide? Identify them. I need answers from all. What is this monosaccharide? First monosaccharide, Yumindu. What is this monosaccharide? Very good. Okay, how we identify this type monosaccharide directly? Fatima, what is this? Yes, it is glucose. Is it alpha or beta? Sarmya? Yes, it is glucose. Is it alpha or beta? That's the issue. Very good. Okay. How to identify them? Okay, now first of all, you can identify this hexagon structure mean, hexagon monosaccharide mean, it is glucose or galactose, hexagon monosaccharide. Okay, remember all hexagon monosaccharides, the first carbon is the carbon number 1 is the carbon after oxygen. This is a carbon number 1. This is a carbon number 1. This is a carbon number 2. This is a carbon number 3. And this is a carbon number 4. This carbon number 1 and carbon number 4, very important for identification. Okay, now by shape of the monosaccharide, if it is hexagon shape, it is glucose or galactose. Not fructose, glucose or galactose. But we can identify what is the exact monosaccharide by first carbon and fourth carbon. Very important. Okay, now fourth carbon. Fourth carbon, if it is OH downward, in fourth carbon, it is always glucose. Remember, fourth carbon OH downward means it is glucose. Fourth carbon OH simple. For carbon only. Now it is OH downward because O downward means exactly OH downward, right? OH downward. O downward means OH downward. OH downward, then it is glucose. How to identify? By fourth carbon. Okay, now you can check the first carbon. First carbon, OH downward, right? O downward. O downward means it is alpha glucose. Alpha. Alpha beta, how to decide alpha beta? According to first carbon. Rehan understood? Remember, alpha beta always decide according to first carbon. Glucose galactose always decide according to fourth carbon. Fourth carbon, OH downward, glucose, OH upward, galactose. First carbon, OH downward, alpha, OH upward, beta. Okay, now it is glucose, right? Glucose, alpha glucose, alpha glucose, alpha glucose, alpha glucose. Okay, what is this? First, identify it is glucose or galactose. It is glucose because fourth carbon O එකක් තියෙනවනේ මෙතන. Then it should have OH. It is glucose. Yes, it is same, no? Alpha glucose. Alpha glucose plus alpha glucose. Then what is this all structure? Alpha glucose plus alpha glucose. Alpha glucose plus alpha glucose. What is this disaccharide? Name? Name of this disaccharide? Alpha glucose plus alpha glucose. Very good. It is maltose. Maltose. I don't know the question. Mame okkama kiyanne hari. Maltose. That's everything. Okay, what is this? What is this? Now it is glucose or galactose. Hexagon shape. No? Okay, now you can check the fourth carbon. It is OH downward. OH downward means glucose. Now OH upward in first carbon. It is beta. Beta glucose. It is monosaccharide. Beta glucose. Beta glucose. What is this? Fourth carbon OH downward. It is glucose. First carbon OH downward. It is alpha glucose, right? Alpha glucose. Then number I think you all can identify them. Okay, what is this? Okay, if it is pentagon shape monosaccharide, no need to think again. It is whatever fructose, alpha or beta fructose, alpha or beta fructose. Okay, how to decide it is alpha or beta? How to decide alpha or beta? According to this carbon. According to this carbon. Okay, if it is hydrogen upward and CH2OH downward, it is beta. It is beta. Actually, it is OH. It's a mistake. OH upward and CH2OH downward, it is beta. If it is changed, OH downward, same as alpha glucose, beta alpha galactose, OH come to downward, it is alpha. Now it is beta fructose. Beta fructose. Beta fructose. Okay, alpha glucose plus beta fructose. What is this disaccharide? What is this disaccharide? What is the name of this disaccharide? It is sucrose. Sucrose. Then if you can identify them, everything, the below questions are very simple, right? Okay, what is this? Can you send me the full name of this structure? Salmia, can you send me the full name of this structure? The full name of this structure? No, Rehla, not glyceride. Yes, it is triglyceride. Why? This is a glycerol. Glycerol. This is a glycerol and the 3 fatty acid. 1 glycerol and 3 fatty acid. 1 glycerol and 3 fatty acid combined by ester bonds. They are ester bonds. They are ester bonds. 1 glycerol and 3 fatty acid combined by 3 ester bonds, then make the triglyceride, not glyceride, triglyceride, triglyceride, triglyceride. It's a type of lipid. Triglyceride, triglyceride. Okay, now let's move into question. Now very simple. Name the reagent that can be used to identify biomolecule name as W. What is a W biomolecule? W maltose. What is the What is the chemical? Name the region that can be used to identify the biomolecule named as W. What is the biomolecule? Maltose is reducing sugar or non-reducing sugar? Maltose is a reducing simple sugar, type of simple sugar, reducing sugar. Now we can simply identify by what's the region? Benedict region, yes, Benedict region. Benedict or Felix. Benedict or Felix region. Which biomolecule mentions above given red color in Sudan tree test? Okay, what is the biomolecule? Sudan tree test we use for lipid identification test, right? Then only one lipid type given here. It is S, Z, 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 Z. Z. Good. Z. The structure of X belongs to which group of carbohydrates? X. What is the X? X. What is the group? It is beta glucose. Beta glucose. The structure of X belongs to which group of carbohydrate? Is it monosaccharide, disaccharide, or polysaccharide? Simple, it is monosaccharide, right? Monosaccharide. Monosaccharides. Name the regions that could be used to identify the biomolecule X and write the color of the region prior to the test. Okay, name the region that could be used to identify the biomolecule X. Okay, what's the X mean? Beta glucose. Beta glucose. Okay, what is the answer? Beta glucose. What is the region? What's the region? The same question again asked, right? Yes, very good. It is Benedict solution. Benedict solution. Actually, solution or reagent. Actually, this is not the answer. The Benedict solution previously asked. Now this part additionally asks, identify the biomolecule X and write the color of the region prior to the test. Okay, what is a prior to the test? Again, culling before doing test. What is the color of Benedict? It is blue color. Yes, blue in color. Blue in color. What color confirm the presence of biomolecule X when it is tested with reagent mentioned in previous part? Okay, what is the color variation? Finally, it's come to brick red precipitation. Brick red precipitation, I already explained. The brick red mean very dark red color. Very dark red color. Okay, what is the color variation? Blue. Actually, this question asked in the final brick red precipitation, but better to write down full color variation, right? Then you no need to take risk here. Okay, blue change into what? Blue color change into green. Blue change into green. Green change into yellow. Yellow change into orange. Orange change into brick red precipitation. Brick red precipitation. Brick red precipitation. Brick red precipitation. Which of the above biomolecule is present in beetroot and sugarcane? Which of the above biomolecule is present in beetroot and sugarcane? Okay, beetroot and sugarcane mainly present sucrose. I already explained in the lesson. Okay, the sucrose structure, what is the name? What is the letter? This is sucrose. Why? Why? Okay, that's a 2016 question, I think. Yes, 2016 question. Any difficult question? No, Ola? Simple, right? Who correct all questions in 2016 question? Raisan? ඔක්කොම හරි කාගේ? No, anyone? Dihini? Fatima? Only one part incorrect? Ah, okay. Yeah, we have to check it. Ah, yes. It is not a disaccharide, no? It is not a disaccharide because the bond continue, not a disaccharide. Then it is a polysaccharide. Yes, I forgot that. Okay, this is alpha glucose. Alpha glucose, it is alpha glucose chain. It's a polysaccharide because it's continue. It's continue. It's continue. Is there an effect for our answers? No effect, right? W. Yes. For first one, it is effect. Yes, it is alpha glucose chain. Then it is polysaccharide. It is iodine test. Iodine test. Iodine region. Yes, very good. I miss this point. It's ID test in the, yes, about Benedict is asking in this part. Yes, correct. In first, the first one is a starch actual. It's a starch, alpha glucose chain. Now correct, right? Good. Okay. This is a part of 2017. Proteins are important. Proteins are important type of biomolecule in living organism. Name a reagent that can be used to identify protein. The same question again asking. It is biorate. Name two main shapes of three-dimensional structures of protein. Name two main shapes. What are the two shapes? The first one is a globular shape. Globular shape. 3D shape. 3D shapes mainly two types. Globular shape, like albumin. Albumin is a globular shape. Okay, what is the next one? What is the second type, second shape of 3D shapes? Globular shape and next one? Fibrous, fibrous shape, yes. No. Helical in secondary structure, Joe. Helical and serpil. Wait. Go to secondary structure and the tooth. Yeah, helix and helical and plated sheet means secondary structure. See, they are exam key points, sir. In secondary structure, helical and mainly two shapes, helical and helix and plated sheets. Plated sheets. In tertiary structure, in 3D shapes, 3D shape means tertiary structure. Tertiary structure, it's mainly two types. The first one is globular shape. Is it given in the tube? Yes. The first one is a globular shape. Globular shape. Please highlight this point on the tube. Globular shapes and fibrous shape. Fibrous shape. Fibrous shapes. Three D structure mean tertiary structure always. So 3D structure. No E. Fibrous. Okay, enzymes are the catalyst biological reaction in biological reaction. Though draw the relevant energy curves for an enzymatic reaction in the absence and the presence of enzyme. The theory directly asking, right? Absence and present. Okay, you can. Okay, this name, this X is very important. What is this? Reaction coordinate. Reaction coordinate. Reaction coordinate. Reaction coordinate. It is x-axis. This is y-axis energy. Energy. This is the reactant. Product. Okay, you can smoothly draw the curve. Reactant to product. Reactant to product. This is with. You can name this is with enzymes. With enzymes. Draw a curve more than this level. This is without enzyme. Without enzymes. Okay. If you have all data mentioned, you have full marks. I told enzymes are biochemical catalysts. Then what they doing? They decrease the activation energy of biomolecule reactions. Biochemical reactions, not biomolecule, biochemical reactions. Decrease the activation energy of biochemical reactions. Okay, it's a part of 2017 question. Let's move into 2019. Think. It is given linear structures as well, 2020. And 2023, it's a full question as I remember. Full structured question. Okay, we have two more questions. Okay, 4 types of biomolecules that are used in different industries are given below. Answer the following questions based on the given biomolecules. Answer the following questions based on the given biomolecules. Okay. What is the name of this? How to identify? Okay, first of all, you can name the carbon. This is first carbon. This is your first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon. Now it is a hexagon. Hexagon, how you can identify? It has 6 carbons. 6 carbon. 6 carbon. Okay, it is hexagon. Okay, hexagon. First carbon is aldehyde group. First one is aldehyde group. Then it is glucose or galactose, right? Aldehyde group. It present aldehyde group mean it is a aldose. It is an aldose. Aldose තියෙන්නේ මොනවද? Hexose aldose මොනවද තියෙන්නේ? Glucose and galactose only, because fructose is a ketone. Fructose is a ketone. Therefore, it is glucose or galactose. Now tell me, is it glucose or galactose? Glucose or galactose? Tehlan, is it glucose or galactose? Yes. How to identify glucose or galactose? Glucose or galactose identify according to third and fourth carbon. Okay, now if it is with aldehyde group, only third carbon difference. With aldehyde group, only third carbon different, other all carbons are same. That is a glucose. That's a glucose. Okay, if you want, I will draw what is the structure of galactose, then you can compare this. This is the galactose. I will draw in same format. Hydrogen, oxygen. This is the first carbon. Second carbon, hydrogen, OH. Third carbon, hydrogen, OH. Fourth carbon, hydrogen, OH. Fifth carbon, hydrogen, OH. Hydrogen, OH. CH2OH. Okay, this is the structure of galactose. Then what is the difference? The difference is first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth. Oh, 1, 2, 3, 4, 5, 6. I have additionally add carbon. This is CH2OH. CH2OH. Sixth carbon is CH2OH. Okay, now you can see how to identify galactose. In galactose, first carbon is aldehyde group. Then it is aldose. You can say it is glucose or galactose. In the carbon chain, in the linear carbon chain, third and fourth, both carbon difference from other carbons, that is always galactose. Third and fourth, dekama change වෙලා නම් තියෙන්නේ, that is galactose. Only third carbon is vary, that is glucose. Remember, Rehlan? Any doubt of this part? Sarmya? Clear or not? Please send me quickly. Today we need to start first lesson as well. Any doubt? Okay. Only third carbon change, it is glucose. Third and fourth both changing, it is galactose. Okay, what is this? It's an amino acid. How to identify common carboxylic group, amine group, and hydrogen group. Now it is a special amino acid. What is the name of this? What's the name of this amino acid? It is glycine, right? That's the most simple amino acid in the world. Glycine. Glycine. What is C? CH3, CH2 into 14, COOH. This is R carbon group, right? This is R carbon group. R carbon group combined with COOH group. It is, yes, fatty acid. Fatty acid. Okay, what is this? Now it is a polysaccharide. You can't say it is disaccharide because it's continue n number of polysaccharides. So n number of disaccharides combining continues. Okay, what is this? What is the structure of this? This is alpha glucose, and continuously alpha glucose, right? Then it should be starch or whatever polysaccharide. Alpha glucose chain. Okay, let's move into questions. Which biomolecule or molecules contain an aldehyde group as functional group? Okay, aldehyde group means COOH group. COOH group. Only B and C. Amino acid and fatty acid. B and C. B and C. Amino acid and fatty acid. Which biomolecule contain a carboxylic acid group as a functional group? Sorry. Mistake. It's asking aldehyde group. Mistake. Aldehyde group only contain aldose, right? Sorry. It's only contain aldose. It's only contain aldose. Okay, this is the A is the aldose. And again in polysaccharide also alpha glucose there, right? That one also aldose. Then aldehyde group as functional group A and D. Sorry, mistake. Who correct this? Who got A and D? Raise hand. No, anyone? Dehini correct? Fatima? No. Yeah, only A covered there. No, D also alpha glucose there. Then alpha glucose contain alpha. Which biomolecule contain carboxylic acid group as functional group? Carboxylic acid group in previously මට මේ change වුණා මේ දෙක වැරදුනා පැටලුණා. Carboxylic group means COOH. Carboxylic group COOH. It is amino acid and fatty acid B and C. B and C. Which biomolecule provide a positive result for the iodine test? Iodine test. Iodine test positive result only starch, right? Starch. Starch is the D. Starch is the D. D is the starch. Name a suitable test to identify biomolecule B. B. Glycine. What is the test? Biurate test. Yes. Biurate test. Now you can understand 2015, 16, 20, 21. Same questions again and again asking, right? Same exam, same question pattern, same question order. Lot of questions based on identification test. Okay. See, identification test, biurate test. Identify which biomolecule or its derivative given above contains in each industrial product mentioned in the table. Write the letter that represent each identified biomolecule in the following table. Cotton threads. Letter that represent the biomolecule. Okay. Cotton threads. Cotton threads. Cotton mainly contain beta glucose. Beta glucose. It's A biomolecule because cotton means cellulose. Cellulose mainly made by beta glucose. A. Soap. Soap, after industry chemistry lesson, you can understand soap production. We mainly use glycerin and fatty acid. Sorry, fatty acid is a main byproduct, main raw material for soap production. Then C, soap production. Sugar again, it's glucose, right? Glucose required for production of sugar because glucose and fructose, okay, they are the most relevant letters. Okay. Okay, next part 2023 question. Okay, who correct 2020 question all parts? It's a very easy question. Very good. Sabir, Sarmia. Correct, very good. Okay, good. 2023. Very new syllabus question. Most of the living organisms directly or indirectly depend on polysaccharides. Sorry, polysynthesis, glucose. Sorry, photosynthesis. Sorry. Glucose is a main product of photosynthesis, can be polymerized to produce various biomolecules. Fill the blanks given in the following questions to get the balanced chemical equation for the photosynthesis. Okay, photosynthesis balanced chemical reaction is asking. Okay, that we again discussed in our cell structure lesson. Okay, what are the main raw materials for photosynthesis? Carbon dioxide and water. Water given. Then balancing number asking. Okay, the glucose is the main byproduct. Sorry, main product. Glucose is a product. What is the next product? Oxygen. Oxygen is the main second product. Okay, how to balance this? Now this side 6 carbon and 6 carbon. Yes, therefore methane 6 dala. It's already given. Now how many hydrogens? 12 hydrogens. Therefore I have to add 6 here. Then how many oxygens? 6 plus 2, 8. Now the left side oxygen 12 plus 18. 12 plus 6, 18. Now we have to add 6. Now 12 plus 6, 18. This is a balanced chemical equation for the photosynthesis. Name 2 main photosynthesis pigments. That's based on cell structure. Okay. Mainly 2 photosynthesis pigments. The main pigment is chlorophyll. Chlorophyll is the main pigment. Chlorophyll. 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 The second one is a carotenoid. That's another one. Carotenoid. Carotenoid. That's one also photosynthesis pigment. Carotenoid. 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 Carotenoid and chlorophylls. They are the main photosynthesis pigments. What is the group of carbohydrates that glucose belongs to? Glucose belongs to carbohydrate group is monosaccharide. Structure of different type of carbohydrates are given below. Answer the following questions related to those structures. Okay. Samely, let's identify them as a practice. What is this? Now, this is your chance. You can send me, I'll write the structure. Okay, you can send me the name, I can write. Rehlan, what is this? Salmia? Very good, Salmia. Yes, all are correct. It is glucose because fourth carbon OH downward and first carbon OH downward, it is alpha glucose. What is this? Dihini? No, no, I need the full name. Salmia. It's a disaccharide name. Fatima? Yes. That's a combination of two alpha glucose, then it is maltose. Alpha glucose, maltose. What is this? C. Okay, it's a continuous one. It's a continuous one. Alpha glucose chain. Then it should be starch or amylose. Amylose tama mehema වෙන්නේ. Amylose or starch කියන්න පුළුවන්. Amylose. Okay, what is this? It is fructose. It is alpha or beta? Is it alpha or beta? Rehlan? Very good. It is alpha. How? This is a carbon number 1. Actually, in fructose, this is a carbon number 1. This is carbon number 2. However, this OH downward mean alpha. Alpha fructose. So, what is the disaccharide formed by combining of A and D? A and D. A is alpha glucose. D alpha fructose. But it is not correct. They expect the answer sucrose, but it has a mistake. Okay, alpha glucose and beta fructose, but they given alpha fructose. It's the answer sucrose, no problem. Sucrose. Which of the above biomolecule contains an alpha 1,4 glycosidic bonds? What's the meaning of alpha 1,4 glycosidic bonds? Alpha 1,4 glycosidic bonds. Okay, alpha 1,4 glycosidic bond mean 1,4 mean 2 carbon numbers. I explained in the lesson. Okay, this is an alpha 1,4 glycosidic bond because this is first carbon, this is fourth carbon. The glycosidic bond formed between first and fourth carbon. Okay, that's the meaning of alpha. Now it is alpha. This is alpha, right? Both alpha. That's why we called as alpha 1,4 glycosidic bond. Then B is correct for alpha 1,4 glycosidic bond. See this one? Yes, that one also alpha 1,4 glycosidic bond. Therefore, A and C. A and C. A and C. alpha 1,4 mean 1,4 කියන්නේ the carbon number. 1,4 mean carbon numbers. The glycosidic bond form carbon numbers. Mention an enzyme that hydrolyzes C to its monomers. What's the meaning of C? C is starch or amylase. Sorry, amylose, amylopectin. What is the enzyme? Your chance. What is the enzyme? Amylase polysaccharide chain. Sorry, amylose polysaccharide chain. How we can break down into glucose again? How we can hydrolyze into glucose again? What is the enzyme? What's the enzyme? Kabir? What is this enzyme? Yes, very good. Amylose breakdown by amylase enzyme. Amylase enzyme. And starch breakdown by amylase enzyme. Okay, final part. Which of the above biomolecule is an example for a ketose sugar? Ketose sugar. Ketose. Not aldose, ketose sugar. Send me answer. A or B or C or D. Ketose sugar. It should have ketone group. Yes, ketone group. It is always fructose. Okay, in 2023, fourth question. Who correct all parts of fourth question? Raise hand. මේ ටික හරි කාගේ? B question again. Okay. Okay, B question asks the glycosidic normally good Yumidu. Okay, normally they are glycosidic bonds. No? These glycosidic bonds, we can give names for glycosidic bond according to carbon name. Mehema glycosidic bonds තියෙනවා. Different types. See? This is CH2. CH2OH. And this another it's CH2OH, and this is hydrogen. Hydrogen OH, hydrogen. In polysaccharide formation, in polysaccharide formation, I told, do you remember? I told in amylose is in starch formation. Amylose is a glucose chain without branches, but amylopectin is a glucose chain with branches. These branches are made. Then maybe the glucose chain same as 4 glycosidic bonds, first carbon and fourth carbon glycosidic bond. Then it is form a glucose chain, polymer chain. Monomers glycosidic monomers bind with glycosidic bond and make as a chain. Okay, that's called as polymer chain. That's the example amylose is enzyme. Amylose is a protein chain. It is given in the tube, but in amylopectin, this type different glycosidic bonds also forming like this. Then they we called as 4 to 6 glycosidic bonds. 4 to 6 alpha 4 to 6 glycosidic bonds. තව මෙහෙමත් තියෙනවා. මේ මෙතෙන්ට connect වෙන ඒවාත් තියෙනවා. They we called as alpha 1 to 6 glycosidic bonds. Normally in our lesson I explained amylopectin, in the formation of amylopectin polypeptide chain. Go to tute amylopectin. See, they are the alpha 4 glycosidic bonds. First carbon, fourth carbon, alpha. Alpha can may occam glucose alpha nisa. Okay. If you got amylopectin, see, these chains are 1,4 glycosidic bond, alpha 1,4 glycosidic bonds, but these branches are made by alpha 1,6 glycosidic bonds. Amedi alpha 1,6 glycosidic bonds. In the tube, it is given alpha 1,6 glycosidic bonds. In our syllabus, amylopectin, for production of amylopectin, 1,4 glycosidic bonds and 1,6 glycosidic bond alpha. That's only important, but different other very complex polysaccharide formation, these 1,4,6 glycosidic bonds and different types glycosidic bonds are forming. The name given according to the carbon number. First one and 6th one, that's why 1,6 glycosidic bond. Clear? Okay, good. Any other doubt of biomolecule lesson? I'm going to complete the biomolecule lesson now. Rehlan, everything okay? Okay, that's the end of biomolecule lesson. Okay, next I'll move into our next lesson revise into heat lesson, not heat, force lesson. Okay, I'm not going to explain again measurements, area and volume, trigonometry type, very simple lessons. I'm not going to explain again. You can go through notes and revise everything. For next week exam, everything required, okay? Area, volume, trigonometry, Pythagoras, everything required. Okay, force. Do you need break? Now 8:22. Okay, take a break and join again 8:35. We start our next new lesson, force. Okay, join 35. I start 35. Okay. Okay, let's move into force lesson. I will quickly revise these theory parts, and I hope to do a lot of calculation in force lesson, because in force lesson and work energy and mechanical properties, combining questions always asking. I hope to revise again mechanical properties and work energy power as well. Then we can discuss more exam type advanced question in the class. Okay. Okay, what's the meaning of the force? That's a simple definition. That's an external agent. If by this external agent, if we can move this object, sorry, yes, stationary or rest object, if we can move by this, if we can uh, move this object by this external force, or if we think moving object, already moving object, change its velocity, or that means speed up or stop this object. However, an external agent change the motion type of any object, we called as a force. Okay, called as a force. Next, third point, the force is an vector always. It has a direction as well as magnitude both. Magnitude and direction both. Therefore, the force is an vector. The force is a vector. Force is a vector quantity, right? Okay, if you got the nature of the force, there are three factors necessary to fulfill describe the force. Okay, the first one is the magnitude of the force. Magnitude of the force. The third one is the direction. Yes, that's why we called as vector. It's a vector quantity. And the point application of the force, like this. Normally, the force is expressed by an arrow. I think you can remember. The force is expressed by an arrow, right? Like this. Arrow. The arrow head describes the direction of the force. The length of the line describes the magnitude of the force. The length described, as example, think 1 centimeter of this line described 5 Newton. Then if you got 3 centimeter line, think it is 3 centimeter, then this arrow describe 15 newtons. 15 Newton describe this arrow. 15 Newton. 15 Newton described by this arrow. Okay, then this is the direction described by the arrowhead. The length of the line describes the magnitude of the force. Think this is the starting point of the arrow. This is the acting point of the force. This is the acting point. This is the direction. This is the direction. This is the acting point of the force. 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 Okay, that's the meaning of application, point of application of force. Okay, as you already know, the standard SI unit of the force is a Newton. The Newton is the standard unit. Yes. Okay, that I already explained. Okay, give me 1 second. Okay, the second part of the lesson, Newton's law. Newton's law. Okay, this is most important lesson because this exam always in exam not asking question directly in force lesson. In exam always questions coming based on combination questions. Like work energy power question coming based on force, well, a moment of force and everything as a combined question, and mechanical properties questions coming combining with force and work energy lesson. Okay, always therefore our target of this January month, actually these 2 weeks and January month, our main target complete force, mechanical properties and work energy power. Then it's a large part is it's a considerable part of our syllabus will be covered if we cover this force, mechanical properties and work energy power. After that we can move into our statistic. Very important. Statistic, you know, compulsory question in exam, essay question, and 2 or 3 maths MCQ questions. After these 3 lessons, we can move into statistic and coordinate geometry lessons. Okay, however, now according to new decisions in education department, your exam not exceed, actually they have scheduled before this disaster. Then it was August 10th, no? 10th of August. Then according to new schedules, I think it is not exceed more, approximate 2 to 3 weeks only changing. Can extend karanne 3 to maximum 3 weeks. Maximum 3 weeks. Therefore, end of August, you have exam. End of August or first week of September. However, you have 7 months. Now this month, today is 16. You have only 7 months. It's not a long time, very short with your workload. It's a very limited time. Therefore, now very important, manage your time. If you have a perfect time schedule, perfect plan for work this next 6 months, in final week you can organize every works and ready for the exam way. Okay, this first 6 months of the next year 2026, January to June, first 6 months, it is very important and your future deciding time period. Okay, therefore responsible, you have to work in responsible about your work, about your life now. Within this final 6 months, means January to June. You have to prepare a work plan for how you what are the parts you complete within January months. Not only SFT, I think no problem. Other subjects, ICT, BST, ET, how to manage and with our workload in SFT from January, you have huge workload. Okay, you have exams, a lot of exams. And now I think up April, from April you have 2 exams per month. Then Satyak, you have exam. You have this week you have exam, again next week you have exam. Satyak. Therefore, now this is a time you have a lot of free times. No, you don't have workload now. This is the time, complete everything and ready for the exam. Okay, Newton's law. Okay, how many Newton's law? There are three main laws explained, introduced by the Isaac Newton. Isaac Newton. Okay, the first law, I think you already know. The first law is the if any object is rest, sorry, if there are no unbalanced force act on any object, this is the first law. If there are no any unbalanced force, no any unbalanced force mean object already balanced, right? Object already balanced. 5 Newton, 5 Newton, it's no any unbalanced force. If there are no any unbalanced force or resultant force, unbalanced force mean resultant force, I think you can remember. Unbalanced force mean resultant force. If there are no any unbalanced force, act on this object, then this object, if it is rest object, keep rest, and if it is moving with uniform velocity, that's the Newton's first law. If no any unbalanced force, remember, if no unbalanced force, rest object rest and rest object keep rest, and moving objects moving with uniform velocity. Okay, that's the meaning of the Newton's first law. Always, if any object is balanced, it's moving with uniform velocity, or the object is stationary, it is rest. Okay, that's the story behind the Newton's first law. Okay, what's the meaning of Newton's second law? Newton's second law is a important part. Newton's second law is, if there are any unbalanced force act on this object. In previous law, there is no any unbalanced force act on this object, the object already balanced. In Newton's second law, he explained, if any unbalanced force act on this object, unbalanced force act on any object, 10 Newton, 8 Newton. Now, unbalanced force means resultant force. The resultant force, 2 Newton resultant force into this direction. 2 Newton resultant force into this direction. Now, it is always accelerating. If there are any unbalanced force act on any object, the object always accelerating into unbalanced force direction. It's always accelerate to unbalanced force direction. Okay, always accelerate to unbalanced force direction. Now this unbalanced force, this acceleration directly proportional to unbalanced force, and this acceleration inversely proportional to the mass of the object. Inversely proportional to the mass of the object, that we called as a second law of Newton's law. Okay, what is the second law? If there are any unbalanced force act on any object, unbalanced force act වෙද්දී, in previous law there is no unbalanced force, object already balanced. But in the second law, if there are any unbalanced force act on any object, what happened? It is accelerating. This acceleration directly proportional to the unbalanced force, and acceleration inversely proportional to the mass of the object. Acceleration inversely proportional to the mass of the object. Okay, this is the second law. According to Newton's second law, we can get our common expression F equal ma. F equal ma. F equal ma. Okay, how to get this relationship? Now, what is the Newton's second law? Acceleration directly proportional to unbalanced force, and acceleration inversely proportional to the mass of the object. Now, simply understand, acceleration directly proportional to F into 1 over m. That's a relationship. Okay, according to this relationship, that's a common relationship. Now, acceleration directly proportional to F over m, right? F into 1 F over m. It means mass of the object. Now, what happened? I want to remove this proportional mark. Then what I can do? We can use equal and constant. This proportional mark replaced by equal and add a constant. Add a constant. In Newton's second law, it's constant K. Remember, K F over M. F over M. I told in experimentally this K value have found it is 1. Then by cross multiplication, we can get, by cross multiplication, we can get A over F over M. F equal MA is our basic equation of Newton's second law. That's a Newton's second law. Okay. Okay, do we remember what's the meaning of the momentum? Momentum. Momentum. What's the definition of momentum? Momentum. Not moment of force, momentum. Raylan, what's the meaning of the momentum? In O level time also you did. Momentum. Yes, the reluctance of any object to change the motion type. The reluctance of any object to change the motion type. As example, if we think moving vehicle, moving vehicle. Okay, actually for damage in an accident mainly the reason is a momentum. If we think moving vehicle, the vehicle not its reluctance to change the motion. It is motion type is moving with whatever acceleration or uniform velocity. Okay. Now in a sudden thing it is hit on a whatever another vehicle or whatever barrier. What happened? The object not like to change the motion type suddenly. It has a reluctance. Due to this reluctance, what happened? It's a huge damage. The damage is huge because that actually this damage depend on the mass and this momentum depend on the mass and velocity. Now you can understand in practically accident එකක්ම ගන්න පුළුවන්. Mass and velocity. Now think tipper, large container accident with whatever barrier. Then what happened? It's a huge damage, right? What is the reason? It's a huge mass. When increase the mass, this momentum is increasing. The reluctance to change the motion type. It can moving object එකක් stop කරන්න තියෙන අකමැත්ත. The reluctance to stop a moving object. It is greater with higher mass objects. Okay, with mass increase, the momentum in P, right? Yes, momentum P. momentum. Momentum increasing. With mass, momentum increase. Remember, in an accident, what happened? If it is a large vehicle, the higher mass, the damage is large. What is the reason? The momentum, the reluctance to change the motion type is greater. Okay, if we think velocity, the vehicle accident in a greater velocity in a highway, then what happened? The damage is high. What is the reason? Velocity increase, the reluctance to change the motion type is increased. Neither. Velocity increase with it, the reluctance to change the motion type is increased. Okay, therefore, we can get a relationship between P, momentum, P equal mv. P equal mv. P equal mv mean the momentum equal mass into velocity. The momentum equal mass into velocity. Mass into velocity. Mass into velocity. The momentum equal mass into velocity. Okay, this is the momentum is a fundamental concept in physics that describes the motion of an object, which means it's a vector quantity and it has moment, direction and magnitude both. We can get the momentum by mass multiplying by velocity. Mass multiplied by velocity. P equal mv. Okay, now we discuss two equations, right? F equal ma, momentum equal mass into velocity. Momentum equal mass into velocity. Okay, what is the unit of the momentum? Amina, what's the unit of momentum? Dehini? What's the unit of momentum? No. True. P equal mv. Then it is kilogram ms minus 1. Velocity ms minus 1, not ms minus 2. Kilograms meters per second. Kilogram meters per second is the unit. Kilograms meters per second. Kilograms meters per second. Kg ms minus 1. Kg ms minus 1. Okay. Okay, using this momentum, we can explain the Newton's second law in another way. Okay, that in few years, 2 to 3 years, there was MCQ question from the second method of Newton's second law. Okay, this is momentum method. This is acceleration method. This is acceleration method. Is it given here? Not given. This is acceleration method. Acceleration method. Newton's second law. In acceleration method, we can get F equal ma correct. But there is another way that we call as momentum method. Momentum method. Okay, now you already know what's the meaning of momentum. Okay, the force. Okay, according to momentum, if we think the unbalanced force applied on an object proportional to the rate of change of momentum. Okay, very important this sentence. The applied force of on any object, unbalanced force actually F, directly proportional to the, this is the Newton's second law in second way. In Newton's second law in second way. The unbalanced force directly proportional to the rate of change of momentum. This is the theory. The unbalanced force directly proportional to the rate of change of momentum. Before that, do you all have this tute? I forgot to ask. I think you all have. Oh no. No. Hmm. If not, I will send in first week of January. I will send you a tute pack. With this tute pack, I will send you the January tute pack and first tute. For now, I can give you PDF. Okay, I will share this PDF into our revision group. January month, you have a full tute pack. If not, I'll send this tute with this tute pack. Dehini, do you have this tute? Oh, okay. I'll send it. Okay, you can get the soft copy of the paper, PDF in the group now. Okay, okay, okay. This is the Newton's second law in second way. In second way. In first way, what is the first way in acceleration method? The acceleration directly proportional to the unbalanced force and acceleration inversely proportional to the mass of the object. That is a acceleration method. The second method we called as what? Momentum method. Momentum method. Momentum method. Okay, in momentum method, if there are any unbalanced force act on any object, this unbalanced force directly proportional to the rate of change of momentum. Rate of change of momentum. Rate of change of momentum. Okay, what's the meaning of the rate of change of momentum mean? Rate of change of momentum. Now we have to clarify this sentence. Rate of change of momentum. Okay, rate of change of momentum means change of momentum within unit time. That's the meaning of rate. Speed again. The change of momentum. Change of momentum in a unit time. That's the meaning of rate of change of momentum. That's the meaning of rate of change of momentum. හරි අපි තව ටිකක් සිම්පල් කරගත්තොත් the unbalanced force directly proportional to the change of momentum mean final momentum minus initial momentum. Change of velocity, right? Final velocity minus initial. Change of momentum mean final momentum, final P minus initial P. Initial P. P mean momentum. Divide by time. This is the rate of change of momentum. This is the rate of change of momentum. Understood, Joel? Dihini? Are you clear? Rate of change of momentum? Rate mean already, you know, last week we discussed rate of reaction. Yes, rate mean unit time. Rate mean unit time. Rate. Change mean difference. Difference. That's why I got final momentum minus initial momentum divided by time is the rate of change of momentum. Okay. According to Newton's second law in momentum method, the unbalanced force directly proportional to the rate of change of momentum. This is the concept. Okay, let's see. Okay, now according to the given diagram, unbalanced force directly proportional to the final momentum. What's the final momentum? Mass into velocity, right? mv, final velocity, final momentum. Final P mean mv minus initial velocity. Initial velocity u, initial momentum m into u, mu divide by time. Okay, now the unbalanced force directly proportional to, now you can see in upward part the m is common for both because same object I can get out this m v minus u divided by time. Okay, what's the meaning of the now v minus u? V minus u mean final velocity minus initial velocity. Final velocity minus initial velocity mean velocity difference. Velocity change divided by time. What is this? Velocity change divided by time. Oh, the velocity change in a unit time. What is this? What's the name of this? Rehlan? What's the velocity change? අපි මේ part එක විතරක් ගත්තම. What's the name of this part? Yes, very good. Acceleration. Okay, now we can see the unbalanced force directly proportional to the rate of change of momentum if directly proportional to the MA. If directly proportional to the MA. Now directly proportional mark we can remove. We can equal KMA. I told K value have found it is 1. Now we can get F equal MA is our second equation according to what is the concept? Momentum theory. Momentum theory. According to momentum theory. Okay, this is the method. According to momentum theory, we can get F equal MA, Newton's second law equation. This is the second way of Newton's second law equation. Okay, now you can remember Newton's second law expression. There are two methods: acceleration methods and momentum methods. What is the acceleration method? The unbalanced force directly proportional to the unbalanced force and acceleration directly proportional to the unbalanced force and acceleration inversely proportional to the mass of the object. You have to by heart them. Remember, in second method, using momentum method, you can explain the unbalanced force directly proportional to the rate of change of momentum. Rate of change of momentum. Rate of change of momentum. Okay. If you want, take a screenshot. Okay. Now the question asks, what is the meaning of 1 Newton? 1 Newton. Can you define? 1 Newton. Okay, that was the exam question. What's the value? What's the meaning of 1 Newton? What's the meaning of 1 Newton? How we can define 1 Newton? Yes. Now it's very simple. We have equation F equal MA. See, you can remember by equation F equal MA. F equal MA. If you got 1 kilogram object, 1 kilogram object. Now, actually 1 Newton mean 1 Newton. Newton is a derived SI unit. Newton is not a base SI unit. Newton is the derived SI unit. In the not you 2027 exam paper we discussed. No? Newton is a derived SI unit. Therefore, force actual unit is F equal MA, M mean kilogram, ms minus 2. This is the actual unit of force. This is the actual unit of force. Okay, then how you can define 1 Newton? 1 Newton. 1 Newton. 1 Newton equal, if you got 1 kilogram object, see, 1 kilogram object, if you want to accelerate by 1 ms minus 1 acceleration, no need to by heart, okay? They are very simple concept. 1 kilogram object, if you want to accelerate 1 ms minus 2 acceleration, the unbalanced force requirement we called as 1 Newton. What is it is given, right? 1 Newton equal 1 kilogram object. If you want to accelerate, if you're going to accelerate by 1 ms minus 2 acceleration, the unbalanced force requirement called as 1 Newton. 1 Newton. Again revise. What's the meaning of 1 Newton? The required unbalanced force to accelerate 1 kilogram object at 1 ms minus 2 acceleration. Okay, this is the definition. The required force, sorry, the required unbalanced force of 1 kilogram object, 1 kilogram object accelerate one ms minus 2 acceleration. The required unbalanced force of 1 kilogram object to accelerate 1 kilogram to accelerate 1 ms minus 2 acceleration. The unbalanced force requirement we called as 1 Newton. Okay. 1 Newton is not a base SI unit. It is a derived SI unit. Actually, 1 Newton mean 1 kg ms minus 2. That's the meaning. This type units we called as derived SI units. Derived SI units. Then why we called it is Newton? Newton කියලා අපි කියන්නේ it is a respect. This Newton's law and force related lot of concept found by Isaac Newton. Even in gravity, right? Even in gravity force, gravity can force එකක් නේ. ඒක පවා හොයාගත්තේ the Isaac Newton. Actually, that's a initial concept he found. I think you know Apple story. This is he actually not found, they identified. He identified there is gravitational force and there are effect with these forces in the earth. Okay, they introduced this concept by Isaac Newton. As a respect of this Isaac Newton, they be using the standard unit of derived SI unit of force. It is 1 Newton. Okay, then what's the meaning of Newton? Newton mean the force requirement, sorry, the unbalanced force requirement to accelerate 1 ms minus 2 acceleration of 1 kilogram object. Okay, this is the story. The unbalanced force requirement of 1 kilogram object to accelerate 1 ms minus 2 acceleration. Okay, the next one, weight, that you already know. Weight is the force always act towards the gravity direction. Okay, in future advanced calculations, the force, very important, force always act towards to the gravity direction. ඒක object එක මෙහෙම තිබ්බත් object එක this direction, object this direction, whatever force is, sorry, weight is act towards to gravity direction. Gravity direction towards to gravity direction mean always this weight and weight force perpendicular to the ground level. Always it is perpendicular to the ground level. Okay, that's the rule. Then what's the meaning of weight? The weight is the force act towards to the gravity. Weight is a force act towards to the gravity. It is a measure of gravitational pull on object's mass. Normally, if you got weight of any object, it is equal to mg. The mass of the object, if you multiply it by 1 gravitational acceleration, it is the weight of the object. Now, think 2 kilogram object. Normally, we think gravitational acceleration 10 ms minus 2. The weight of the object 20 kg ms minus 2 is the actual unit, but that we use as 20 Newton. 20 kg ms minus 2 equal 20 Newton. 20 Newton. Okay, what's the meaning of gravitational acceleration? G. What's the meaning of G? What's the meaning of this G? Gravitational acceleration. How we can define this gravitational acceleration? It's an acceleration. What's the definition? Anyone? How we can define gravitational acceleration? G, simple G. Gravitational acceleration. Anyone? The gravitational acceleration means simply the acceleration due to gravity. Acceleration due to gravity. Think example, think this pen, if I release without any external force, then it is accelerate. It is the practically you can. Now this is a pen. Now if I release this object without any external force, freely release, it's gradually speed increasing or decreasing or same speed. Gradually, normally pen එක වැටෙන්නේ same velocity or acceleration or deceleration. What do you think? Then මේක වැටෙන්නේ acceleration එක්කද same velocity? Yes, it is acceleration. It is everything science, okay? Now, if you got this type object, if I release freely in atmosphere, what happen? There is force act gravity due to the gravity of Gurutvakarshana, due to the gravity force, gravity attraction, there is force act. This is a weight into up downward direction. Into upward direction, air resistant and resistant forces act to air resistance act to upward direction, right? Upward direction. Now, more than this air resistance, the weight is greater, right? More than air resistance, the weight is greater. More than air resistance, the weight is greater. That's why it is accelerating into down direction. That there is resultant force into downward direction. That's why it's accelerate to down direction. Okay, gradually the speed increasing. The reason, unbalanced force. But if you think parachute, what happened? Parachute came. What happened? Parachute, due to this large surface, the air resistance is greater. Air resistance is equal to the weight sometimes. Air resistance and weight is equal, or air resistance is greater. That's why it is uniform velocity. Normally it's uniformly, it's moving to downward. The reason, it has air resistance equal to the gravity, equal to the force, equal to the weight of the person. Are you clear? They are very simple practical things. Therefore, if any object fall down or moving due to the gravity force, we call it as the gravitational acceleration. Any force, any object moving acceleration due to the gravity. Any object moving acceleration due to gravity, we call it as gravitational acceleration. Api onam object ekak. If you got any object, if you release freely, the object moving with object fall down with gravitational acceleration. Clear? Dehini? Y'all? Send message. Normally it's 9.81 value. For our calculation, easy calculations, we use it as 10. Gravitational acceleration in our syllabus we use as 10. In A level, it is a value. Okay, it is 10 for our easy calculation. Okay, this is the mg weight equal mg mass multiplied by gravitational acceleration. You can get the weight of any object. Gravitational acceleration 10. Okay, this is the final Newton's law, Newton's third law. For every action has an reaction in same magnitude, and every action, this is a very simple theory, every action has an reaction same magnitude and opposite in direction. Same magnitude and opposite in direction. Opposite reaction. Okay, if you, they are the examples. Think this child push this right side child. Then what happened? both students moving to opposite direction. Every action has reaction. See, this action has an reaction. The same magnitude and opposite in direction. See, opposite in direction. Opposite in direction. Same magnitude and opposite in direction. Okay, if you got another example, the weight and we called as auto adjustable force. Okay, auto adjustable forces. Auto adjustable forces are example for Newton's second law. Sorry, third law. Third law. Auto adjustable force. Adjustable force. Auto adjustable forces. Auto adjustable force mean while changing one force, the second force changing automatically. One example, the weight 10, the weight, what's the meaning of weight? The force act towards to the gravity direction, right? The weight is mainly act by the object on the surface. This is a weight. Okay, if we think this type object on whatever surface, there is another force at opposite direction that we called as R. This is the perpendicular reaction. Perpendicular reaction force. 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 Okay, think this is this pen rest on my hand. Now the weight of the pen act on my hand. There is another force act by my hand on the pen. That is a perpendicular reaction. This time, this weight and according to Newton's first law, according to Newton's first law, this acting weight and weight given by the pen and reaction force given by the surface is equal. That's why it is rest. That's why it is rest. Now this balance is already balanced. The reason the weight act by pen and the perpendicular reaction act by my hand both equal. That's why it is balance and rest according to Newton's first law. Okay, if we think if we got two pens and place on my hand, then what happened? The weight increasing. How about the perpendicular reaction? The perpendicular reaction also getting same value. Yet same value again. That's why still it is rest. Understood? Now think example. This is a table. This is a table. Okay, it's a table. This is a table. Can we place 100 kilogram object on this table? No issue. No issue mean 100 kilogram in 1000 weight, 1000 Newton weight, 100 kilogram, 1000 equal to this 1000 Newton weight. Perpendicular reaction can be given by the surface. No issue. You can table like 1000 Newton දෙන්න පුළුවන් නම් okay. No issue. But if we think if we double this weight up to 20,000 Newton, if we increase this force up to 20,000, now think this surface, this table cannot give this weight, this reaction force cannot be given by the surface. Again, Table එකට දෙන්න බෑ එච්චර perpendicular reaction එක. Then what happened? The weight is greater than perpendicular reaction. Unbalanced force, it is breakdown. It is break. Okay, that's the story. Always, if we think any object rest, it's all balance, all forces are balanced. They make a balance. The mehin force mehin all are balanced. The weight and perpendicular reaction balance. If there are any unbalanced force, resultant force act towards the unbalanced force direction and accelerating according to Newton's second law. Understood? Any doubt? Any doubt? Rehelan? Clear? Okay, now the perpendicular reaction is an auto-adjustable force. Salmia, clear? Perpendicular reaction is an auto-adjustable force with weight increase. What happened? Perpendicular reaction also getting same value. That's why we call adjuster now. Auto-adjustable force. It's auto-adjustable. Okay. Okay. That's another example. If you got tension force, weight and tension force like this. Weight and tension force. Not think this is mass. This is an string. It is connected by string. Okay, mg is the weight equal mg, right? Weight equal mg. This m equal to this weight, there is another force act towards the opposite direction that we called as tension. Tension of the object. Tension on the string that we called as capital T. Tension. Tension. Okay, the tension also an auto-adjustable force with weight increase, tension increase, get the same value. Get the same value. Okay, now think if you're going to increase the weight, gradually increase the weight, now it is 1 kilogram, 2 kilogram, 5 kilogram, and increasing, gradually increasing. Right? If we increase this 1 kilogram, 2 kilogram, and increase this weight, at some level, it's come to maximum tension of this string, right? In elasticity lesson, we can discuss again mechanical properties. At some level, the tension of the string come to maximum level. After that, if we increase weight again more than this maximum level of the string, what happened? The weight is greater than the maximum level of the tension. At that point, the string will be break down due to this unbalanced force. The balance will be breakdown. At that point, at that time, the object will be fall into whatever surface by breaking this string. Okay, that's the story. That's the story of auto-adjustable forces and Newton's third law. Newton's third law. Okay, today we discussed about 2 lessons, basic of force and Newton's law. And next Sunday, we discussed friction's force, and I hope to discuss force resolution as well, because within December I hope to complete this first lesson, and January I want to complete work energy power and mechanical properties as well. Okay, any doubt about any doubt up to now, you can ask. Any doubt? Dihini? Yumindu? Everything clear, Rehlan? Okay. Okay. Then go through again and complete everything before next week up to now. To now, up to friction force, you can complete everything. And next Sunday, let's discuss about friction force and force resolution. Force resolution, right? And remember, next Tuesday, 6:30 p.m. to 9 p.m. you have an exam. Our first revision exam. Our first revision exam. I will share what is the structure of the paper and time and structure of paper. What are the lessons you want to ready within tomorrow or day after tomorrow? I will send all details about exam into the revision group. Okay, you can ready now. All lessons you have to go through again. All lessons. No more question in work energy power and mechanical property. But other all questions, other all lessons, heat especially, heat and biomolecule especially, and force and measurements, area volume, trigonometry, Pythagoras, rotational motion. Okay, that's all for today. Let's meet next Sunday. Not Sunday, tomorrow. Goodbye.